batch process, we store the data onto the Teradata data warehouse. Later, the data can be used for some analytical purpose. So Teradata is a database which is preferred for a data warehousing, not for OLTP applications. And Teradata, it's an open system. Why we call it as an open system is it can run on multiple platforms like MPRAS, Unix, Linux, Windows operating system, mainframe, and it is compliant with ANSI industry standards. So the semantics, if you see, right, the Teradata semantics, it is the same standards which Oracle, DB2, other databases follow. All are ANSI standards. So even Teradata is compliant with ANSI industry standards. And Teradata, it runs on a single or a multiple node. In the coming slides, we will see what does a single or a multiple node means. And Teradata, basically it's a database server where we interact through various clients, multiple clients. And parallelism is one of the biggest feature of Teradata, where it can handle terabytes of data efficiently. And it is capable of supporting many concurrent users from various client platforms using the massive parallel processing architecture. The architecture of Teradata, we call it as MPP architecture, massive parallel processing architecture. It can parallelly process massive amount of data in an efficient manner. So the architecture we call it as an MPP architecture. And if you look at the history of Teradata, right, it started way back in 1975, and it has released various versions of Teradata. It started with V1R1, V1R2, V2R1, V2R2, like that. And in one of the major release was in V2R in 2003, 2002 V2R5, where it contained some of the biggest features in Teradata, like partial partition, primary index, roles and profiles, compression, user-defined functions, usage of binary large objects, character large objects. Those kind of features were introduced. So currently in the market, right, the running versions are TD12 and TD13 and TD14. So these are the current running versions. All have been outdated basically. V2R6 is no more. None of the customers are currently using that. So everyone has been upgraded to TD12, TD13 and TD14. So these are the current versions. So there will not be much drastic difference from version to version from the user perspective. Only from the system perspective there will be change. From the performance perspective, or if a new feature has been introduced, the syntax and semantics will be applicable for that particular feature. So the current running version mostly in the market is TD12 and TD13. TD14, few customers have been upgraded to that version. And the difference between version to version is like some of the major features which have been introduced in that particular release. Like in TD12, query rewrite, TD13 scalar subquery and no primary index, TD14 temporal feature, columnar feature. These are the two new features which have been introduced in TD14. So we will be looking even at the syntax and semantics of these specific features basically. Not all, but since these are the major features, we will look into the syntax and semantics as well when we discuss the SQL part. And now this slide talks about the architecture of Teradata. What are the various components involved in Teradata architecture? If you see the gray color box, right, this one, the gray color box, this can be considered as a node. So as I said, Teradata runs on a single or a multiple node. So this is a single node. Multiple node means similar kind of a node more than once. So Teradata can run on a single node or a multiple node. And the components involved in this particular node are parsing engine, message passing layer, and access module processor. In short, we call it as AMP. So the parsing engine is the component which will do the syntax and semantics checking. So if any request you send to Teradata RDBMS, right, the parsing engine will check whether the syntax and the semantics are true or not. And it also does the optimization, and it also has the intelligence to distribute the data. To which particular AMP I need to send this particular record. That kind of intelligence parsing engine has. Data distribution basically. So here in this example, right, what the client is trying to do is, the client is trying to insert some bulk number of records into a table, and these records, if you see in the Teradata system, right, this is how the data got distributed. So a single table data is not stored in one particular disk. We are distributing the data across all the amps. So we are basically distributing the load of the table across all the amps. In general, right, Teradata tries to distribute the data in an even fashion. So here 12 records are there in a single table. If we try to insert, so each amp will retrieve will get at most 3 records. So a single table is distributed across multiple amps. Now if at all, if I run any request on top of this table, what happens is the request will be broadcasted to all the amps, and each amp will be performing that particular task in a parallel fashion. So single task is divided into multiple tasks, and multiple tasks are running in a parallel fashion. So that's how parallelism works in Teradata. We distribute the data across all the amps, and whatever request we submit, it gets distributed across all the amps, and each amp will be performing in a parallel fashion on the subset of data. Instead of complete data, it performs operation on the subset of data. That's how it works very efficiently.
Okay, you mentioned parsing engine dispatches request to insert a row. What about selecting data? Is it the same?
Yeah, selecting the same way. The request will go to the parsing engine, and the parsing engine will see whether the syntax is correct or not. If at all it is true, it will send it to the message passing layer. Via the message passing layer, the request will get broadcasted to all the amps. Or if it needs to be sent to group of amps, the request will be sent to group of amps. If it needs to send only to a single amp, the request will send it only to a single amp. Message passing layer is like a communication protocol between parsing engine and access module processor. It will do the communication between these two processes and between the amps as well.
So the flow of data in that case would be in the other way around. So the arrows would point upward rather than...
Yes, upward, yeah.
Yeah, sure. Okay.
In this slide it is showing only an insert, but yeah, as you said, in a select statement, the arrows would pop up.
Okay. Yeah, it's fine.
And message passing, in the message passing layer, right, in addition to the communication protocol, right, it also handles the result set basically. Like suppose in this particular scenario, if I do a select star from this table, what should happen? I should get all the 12 records to my client. So from client I am sending that request, so I need to get all the 12 records. So the parsing engine will get take that request, do the syntax and semantics checking, then via the message passing layer it will pass on to all the amps. Then what will all the amps, what it will do, it will perform the task on the respective disk, get the data and send it to message passing layer. So at the message passing layer, all the result sets will be getting accumulated here, and then the consolidated one will be sending it to the client. So message passing layer also handles the data sets. Whatever the data sets it gets from each and every amp, it gets accumulated into one single set, and that single set will be sent it to the client.
And the other way, when you're inserting data, that's managed by message processing layer. Like, will that decide which data would go into AMP and which one to go to AMP?
No, parsing engine will say, okay, record 2 should go to AMP1. So the request will be sent to message passing layer. The message passing will pass it to AMP. And AMP will try to insert into that particular disk.
Sorry, how does the parsing engine decide which AMP to use for which data?
Yeah, basically a component called hashing algorithm is there. So that will that algorithm will decide when you insert a record to which, based on the value, basically the algorithm is dependent upon the values, what type of value you are inserting. It's a date, time, character, times, anything it can be. It can handle all the different data type values. So based on that, it will decide to which AMP it needs to go.
Okay.
It's a little bit advanced topic. Okay, we'll discuss the distribution in the other class.
Sure. Okay.
So, and one more thing here is each AMP, right, it will try to process only the disk associated with it. It will never try to access the disk associated with any other AMP. So that's why this architecture is also called as shared nothing architecture. The data will be accessed by only to the associated AMP, not to any other AMP. If at all AMP2 wants to access any other AMP data, right, then it will send a request to that particular AMP, make a local copy, and then do the data processing on that particular data set. So basically the data is not shared across any other AMP. That's the reason we say it's a shared nothing architecture. And that is one of the major difference between Teradata and other RDBMS. Teradata we call it as a shared nothing architecture. So when someone asks you what is the difference between Teradata architecture, we can say Teradata is a shared nothing architecture. The data is not shared across the AMPs. And terabyte, it's 10 power 12 bytes, 1000 GB. 1000 GB we call it as a terabyte. And these are the common differences between Teradata and other RDBMS. These differences are pretty old actually, because nowadays even other RDBMSs have come up with a similar kind of architecture. The way Teradata is handling the data, like the data distribution and those kind of stuff. Even other RDBMS has come with similar kind of mechanisms, like Netezza, Exadata with Oracle. The Netezza is an IBM product. So those data warehouses also today they also are in a similar kind of architecture. So these differences were pretty old, but now the differences are very minimal basically. Even the other RDBMS are following the same approach which Teradata was following. So in Teradata we have unconditional parallelism. That means we are not defining parallelism at any particular, we are not defining parallelism at any one particular component. So by default parallelism is being there at each and every component. Like parsing engine, it handles multiple requests parallelly. Message passing layer, it can handle multiple requests parallelly. AMP, it can perform multiple tasks parallelly. And all the AMPs perform the task in a parallel fashion. So the parallelism is there from top to bottom component. And Teradata, as I said, it is not for a OLTP application. It is not for small scale systems. It is only for data warehousing, decision support systems and data warehousing. Why we call it as a decision support system is we can make certain decisions using huge amount of data. That's the reason we call it as decision support system, DSS. And as I said, shared nothing architecture, the data is not shared across any other AMP. And Teradata, yeah, it supports terabytes of data compared to other RDBMS, and it handles billions of rows. And index usage, right, in Teradata, basically in any RDBMS, index usage is for fast retrieval. But in Teradata, right, fast retrieval is possible. In addition to that, better storage is possible, better storage of data. Why we are seeing a good distribution of data is because of index. Because of a particular index creation, this kind of distribution is seen in Teradata architecture, a well distributed data. So that is seen. And some other terms which Teradata drives is, like from the capacity perspective, it can include some millions and millions of records, process some millions of instructions per second, and handle some terabytes of data. And the parallel processing, yeah, that is a feature which makes Teradata RDBMS faster than any other RDBMS systems. And it's a single data store and can be accessed by various client platforms like mainframe application or Windows, Linux and other operating systems. Network attaches, like here in this particular sentence, it can be accessed by network attached and channel attached. Network attached is the mainframe application. Channel attached is the rest of operating systems like Linux, Windows, MPRAS, Unix. Those comes under channel attached. And the fault tolerance, it can automatically detect and recover from some of the hardware failures and software failures. And data integrity is same basically in any RDBMS. Like either a transaction should be complete, or if at all any transaction fails, it should roll back to the previous save state. So even Teradata follows data integrity approach. So whenever any transaction happens, it happens completely. If at all any failure happens, it gets rolled back to the previous state. And scalable growth, yeah, the Teradata RDBMS allows the expansion of the RDBMS system or the capacity of the system without any performance drop. Like suppose if this is my current system, okay, but in future my business is expanding, so I want to add additional nodes. So what happens is the performance of the system will be linearly scalable. If I add one more node, the performance will be double. If I add still one more node, the performance will be triple, like that. So the performance will not have any impact on the system. It expands in a linear fashion. And SQL is the structured query language which is used to access, interact with the Teradata RDBMS. So this is a very brief level overview of the Teradata architecture and the components. Then from the training perspective, so basically we'll be working, the training will be on the Teradata 13 platform on a Windows environment. And from your end, if you want to practice, right, a Linux version is available, a demo version is available in the Teradata website. So I'll be helping out you to download and install that RDBMS in your system, and you can work on that. But it's a Linux version. So basically, it's a VM, virtual machine. You can directly download it on your Windows system and directly open it with a VMware player. No need to install any operating system like that.
Okay.
It's a VM package, completely inbuilt package.
Okay.
So from my end, I will be discussing on the Windows platform, and for some components I will be migrating it onto the Linux platform. But from your end, you will be purely working on Linux platform because the Windows version is not available now. It has been outdated and removed. So now only Linux version is available in that website. And initially we will be going a little bit in detail about the components of Teradata, each and every component and what is its pros and cons. Basically what functionality that component has. So Teradata architecture and the IT components, and then the production mechanism, the recovery and protection mechanism, how the data is protected. Then the technical concepts, how the indexes are being implemented and derived in Teradata. Then comes the storage and retrieval part, how exactly the data is stored in Teradata RDBMS and how we do the retrieval of the data basically, how the distribution happens based on which component. Then a little bit from the SQL part, the DDL, DML and the DCL, and then basic string functions and aggregate and arithmetic OLAP functions. Then we have the join strategies and the join types. What are the different join types and join strategies implemented in Teradata and how internally it works. And then some other external commands from the SQL perspective. Then this is also from the SQL perspective, Teradata objects, various types of objects in Teradata, and then a little bit on DBA part, handling the space, and then the DCL part, granting and revoking. Why we require this particular DBA part is if you want to practice some SQL stuff on Teradata, right? Directly we can't start with the DDL, DML statements. We need to have some DBA part as well. Like how do we need to create a database? How do we create a user password? How do we need to grant the roles and access right to a particular object? For that case, right, in order to practice efficiently, we'll be discussing the DBA part as well, a little bit on DBA front, the permanent space. And then the different type of transaction modes available in Teradata and what are the difference between each and every mode. And then the performance tuning part, like what are the best practices to write a SQL. If you given a request right to you, you can write the request in one fashion. I might write the request in one fashion. A single request can be like a task can be implemented in various fashions, but there will be one approach which will be very efficient. So we'll be discussing the best practices as well and how efficiently we can write SQLs in Teradata, when to use which one, I can simply frame a SQL using a not in clause, inner join, exist clause, but which one to use at which case? So those things we will be discussing from the performance tuning perspective.
Okay.
And then comes the production part, the Teradata utilities, like to perform the extract and load data from flat files to Teradata RDBMS and from RDBMS to flat files. There are various mechanisms, various tools basically, like fast load, multi-load, VTech export import, and TPUM. So we'll be looking each and everything, and the failures. When a job fails, what are the different scenarios a job can fail, and how do we recover? So that in the real time also you will be facing one of the issues which we face here. So if you face that, then how do we overcome that particular failure? Those things we will see. If at all intermediately, if a job fails, how do we recover? So these things will be running it on Linux platform, and then see how we can basically recover that particular failure, so that it will be helpful in the real time for you.
Okay.
And then apart from that, I will be discussing the syntax and semantics of these features. These are new features in Teradata RDBMS. So we'll be discussing these features as well: no PI, scalar subquery, temporal, and columnar. And then apart from that, I will be providing you the material for Teradata Basic and SQL certification. So if you are planning for certification, then you can go ahead as well. So for that, materials and dumps are available.
Okay.
Apart from this, I will be giving my own document actually, which covers all the concepts of which we are discussing here.
Okay.
And one more thing, like once we finish the training, and because this has been this particular template, right, it has been created keeping in mind like students like who are freshers or 1 or 2 years of experience in any database. With that intention, this particular training content has been, because you are very experienced, right? Some concepts might not be useful for you, or you might require some additional concepts if you are already working. So if any concepts or something is missing here, and if you require that information or need some explanation on that particular topic, right, you can let me know. Once our general training is done, at the end I can discuss those topics as well with you.
Okay. Now there are two certifications that are there majorly in developer role. So one is Teradata 14 Basics and SQL. So we are going to cover the contents for these two certifications.
Contents perspective certificate, in that contents, right, there will be additional topics as well, like from the data warehousing perspective, what is schema, like normalization technique, denormalizations, then star schema, snowflake schema. Those things we have not included here in this. That's a theory part completely. So those things I have not included.
But you will be giving material to...
Material I will give you. I will be giving you the material.
Okay, that's perfect. And how long will this training take? 6 weeks?
This will take around 25 to 30 hours.
Okay.
Yeah, around 5 weeks, 5 to 6 weeks.
5 to 6 weeks. And when do you plan to cover this? Saturdays and Sundays?
No, only you are staying in Ireland, right? So mostly it will be this time, 8:30 to 9:30, like that.
Okay. So how do you plan to do it? Every day or?
Yeah, every day around 1 hour. And if
1 hour
possible,
every day.
we can plan in weekend as well, depending upon your availability and my availability.
Okay. Okay.
Yeah.
So will I be the only one, or do you have anyone else?
Not sure, but Raghav said that there were 2 other students as well, one from UK and one from Australia, but they haven't responded yet now. They haven't joined as well. No, not sure if they will join or not. But no issues actually. Even one student is generally I will take class.
Okay.
That's not a problem. But Raghav will inform you about that, the timings and other stuff.
Okay. One last question. It will be handy for me if I can. So once we complete our session, if I can get a recording of these sessions.
Yeah, you can discuss that with Raghav. He will let you know that
Okay.
updates on that, how to get that.
That's perfect. Okay. Okay. Thank you very much for your time.